All right, so today we're going to talk about oxidation reduction reactions. This is chapter 5, section 4. So oxidation reduction reactions are a specific kind of chemical reaction where we transfer energy, right? And so sometimes you'll hear people call them as redox reactions. And these are super essential to all living systems. And so when you're looking to identify, is an oxidation reaction occurring or not, you need to look at a couple of different things. If we're looking at metal ions, so remember when we had an ionic compound, right, a metal and a non-metal, if we have that metal ion, we're going to see a movement of electrons. We're going to have one substance that is going to have electrons, and it's going to transfer electrons to another substance. So that's inorganic oxidation reduction. It's a little bit easier when we look at things that are organic, because we can actually see changes in the number of oxygen atoms and the number of hydrogen atoms. So a little bit easier to recognize in organic things. So first we're going to talk about the inorganic, and then we're going to talk about the organic. So what you see here on the screen is an example of oxidation reduction, right? Whenever you have an oxidation occur, oxidation is electron loss. So you have this orange circle, right? The orange circle started out and it had a set number of electrons, right? And one of those electrons is lost during the reaction. Well, where did it go, right? It didn't really, you really lose it. You can still find it because it got transferred to the other substance. So the red circle picks up the electron. So it didn't have an electron before, and then after the reaction is over, now the red substance has the electron. So the substance that loses that electron, that's the oxidation reaction, and then the reduction reaction is the one that gained the electron. And then to further confuse you, we call the substance that lost the electron the reducing agent because it made the other substance become reduced. And then we call the oxidizing agent the one that actually gained the electron. So we're going to practice with this, and it's going to get, I promise, easier. So one thing to kind of remember, your book has this nice little table that oxidation is always going to involve a loss of electrons. And so this is going to be what you're looking for in inorganic reactions. So a loss of electrons for oxidation, and then a gain of electrons for our reduction. But remember, I said it's going to be easier when we're looking at organic substances, because we're actually going to be able to just count the number of oxygens and the number of hydrogens and know if we're having an oxidation or a reduction reaction. So just kind of keep that in mind, and we'll keep coming back to that. So here's an example. We have rusting. Rusting is an example of an oxidation reduction reaction. And always remember, if you have oxidation, you have reduction. You can't have one without the other. So if you look at these substances, so you're going to start with iron. So you have iron 3 ions that are present in the presence of oxygen. So here we have our iron, and then we are in the presence of oxygen, right? And in that presence, we are going to create iron oxide. So when this happens, you're going to create iron 3 oxide. So when this happens, what you're looking for is who's gaining and who's losing electrons, right? So the thing you have to remember is that these substances by themselves have to end up with a charge of 0, okay? No matter, remember when we were writing our formulas for ionic compounds, right? And we said, how do we know what the charge is on any given compound? We're going to look, and we're going to know that those charges add up to 0. So let's do that for our product over there first, because this is something you're super familiar with, right? So we said that it's iron 3 oxide, and the little trick that you can do also, it told you in the problem that it was iron 3. But if you know your formula, right, what you can do is you can do the reverse crossover. And so the subscript becomes the charge, Fe3 plus and O2 minus. And you just have to double check on the periodic table and look for oxygen. Oxygen's in group 6A, and so it does have a charge of -2. So you can kind of do that trick to know what your charges are for all your substances, right? So if I come over here and I'm just going to write myself a little note on top, and I'm going to say my iron is a +3 and my oxygen is a -2. So I know the charges on the product side, but how about on the reactant side? Well, when we look at these substances, what we're going to look for is that the substances, the individual substances, like 4FeS, this has to be neutral. It has to be, by definition, it has to be neutral. So things that are an element by themselves, these are going to be a charge of 0. Charge is equal to 0, okay? Diatomic molecules also have a charge equal to 0. So now you'll be able to see, okay, is something changing? Yes, we see a change in charge. So when we look at the beginning of a reaction, right, we had iron, and iron was a charge of 0, right? And then we went to our products, and we look in our products, and now we have iron, but this is a charge of +3. So we can see that the charge changed. So you can put your little 0 up there if you want to put your 0 up there, and that's a +3, right? That's just how we write it. So what's happening to those iron atoms? Well, if you're going to have a charge of +3, that means that you have lost electrons. And so those are the ones that are undergoing oxidation. So our iron is undergoing oxidation. Atoms that gain electrons are said to undergo reduction. So what's happening with our oxygen? Our oxygen started out at 0 and is going to a charge of -2. So because we're gaining a negative charge, we have gained electrons, right? And so you can look at any chemical equation and you can figure out what chemicals are undergoing oxidation and which ones are undergoing a reduction. And so then you can look at the different ones and you can say, you can classify them as reducing agents or oxidizing agents. I think that gets kind of confusing. I want you to know which ones are undergoing oxidation and which ones are undergoing reduction. So there's a neat little saying that you can remember in order to keep this straight in your mind, and that little saying is oil rig. So oil stands for oxidation is loss, but what are we losing? Oxidation is loss of what? Electrons, right? Rig, so reduction is gain of electrons, right? So if you just kind of remember that. So if you kind of look in general, right, metal ions are going to tend to lose electrons and they're going to form cations. So they are the species that are going to become oxidized. Just by knowing that metal atoms are going to lose electrons, right? On the periodic table, those are the ones that end up with a plus charge. So we know that those are going to form cations. Therefore, they have to be oxidized. Non-metal, on the other hand, right on the other side of the periodic table, these are the ones that are going to have a negative charge once they become an ion. So they've gained electrons. So because we have anions, we know that they're going to get reduced. So always those oxidation reduction reactions are going to be coupled. And if you remember this little oil rig saying, it will help you to remember what's lost and what's gained. All right. So there are some cases in biological systems where we have metals that are oxidized and reduced. One example is cytochrome C, and cytochrome C participates in the electron transport chain if you study that in biology. And so it's really, really, really important for ATP production. And so how this works, how are you transporting electrons? Well, you have a protein, and so all of this stuff is the protein, right? And inside of that protein, there is an atom of iron, right? And so you have an Fe2 plus, and in a reaction, that Fe2 plus will convert into Fe3. 3 plus, right? And so that iron is undergoing oxidation because we go from a charge of +2 to a charge of +3, right? So we lost our electron. And then the opposite can actually happen later when you need to regenerate the cytochrome C, and it'll go back to the Fe2 plus. Okay, and so anytime you see an iron molecule, an iron ion that's held in place on an organic molecule, we call that a heme group, and we'll come back to that in another chapter. So let's look at an example problem. Determine which of the reactants is undergoing oxidation and which is undergoing reduction. So if I look at these, and I put you a little thing down here that has kind of your cheat sheet there, right? So I know calcium. I'm going to do products going to reactants. Let's see what happens. So my calcium here, I'm a solid. I have to have a charge of 0. I can't be an ion. I have to be neutral. So now when I come over here, CAS, I need to try and figure out what my charges are for my different elements here. So I know calcium is a +2 because it is in group 2, right? So go to your periodic table. This is how you find it. And you see that it is in group 2. So now I want to find my sulfur, and so if I go and look on the periodic table and I find sulfur, sulfur is in group 6A or group 16, right? So that is going to mean that sulfur is going to create a charge of -2. And so if you were to write this, right, CAS, and we had +2, -2, and we cross them over, right, you get 2 and 2. So then you would reduce that to CAS, and that's what we see. So if you wanted to do that kind of reverse crossover, you kind of have to keep in mind, right, if you're CA1, S1, and I just cross them over, I would get 1s, a +1 and a -1, but I know that's not right because I go and check in the periodic table and I see calcium has a charge of 2 and sulfur has a charge of 2. Calcium's +2, sulfur is -2. So sometimes you'll have to like multiply by 2 if you use that method. So just kind of keep that in mind. So I'm going to go back to my thing over here. So I have calcium. It started off in my reactants. This is reactants. This is products. Hello. All right. So my reactants for calcium, I start off with a charge of 0. I look at my calcium in the products, and what do I see? I see that my calcium became a +2. Okay. So now, remember your oil rig or check your little box at the bottom. What's happening here? I got a +2 charge. How did I get a +2 charge? I got a +2 charge because I lost 2 electrons. If I'm going to lose electrons, this is oxidation, right? So calcium is undergoing oxidation. So let's try our other element, sulfur. Sulfur starts out as 0 in the reactants. We go to the products and we see it's a -2. How do we get a -2? We gain 2 electrons. Because we are gaining 2 electrons, this must be the reduction reaction. So our sulfur is undergoing reduction. So that's how you do those problems. Now remember, I said oxidation reduction in organic compounds is a little bit easier because in an organic molecule, when you're looking to see if something is oxidized, if it's oxidized, it is going to either gain oxygen or it's going to lose hydrogen. So same things up here in the table, right? If you're oxidation, it may involve addition of an oxygen or loss of a hydrogen. And so that's what we're going to track and what we're going to look at, right? And then the opposite is true for reduction. It is reduced if it gains a hydrogen or loses an oxygen. So let's look at an example. We have a carbonyl group right here on our compound here, and we call this kind of a compound an aldehyde. And aldehydes are kind of cool because they can be both reduced and they can be oxidized. So let's look at reduced first. If we're going to reduce something, right, It's reduced if it gains a hydrogen or if it loses an oxygen. So I'm telling you that if we go in this direction, we're going to have a reduction reaction. So how do we know that we had a reduction reaction? Well, I'm going to look, okay, I'm going to look at my carbon and I'm going to see what's around my carbon. So here I had an oxygen. Here I have an alcohol, right? That's a functional group of an alcohol. And then I have a hydrogen here, and whoa, I had nothing here, and now I have a hydrogen. So what happened? I added a hydrogen in order to create this alcohol. So once we add this hydrogen here, you can't have a double bond here, and so oxygen will pick up the hydrogen and make the alcohol, okay? So we have in this molecule an addition of 2 hydrogens, and so this is telling me that I have a reduction reaction. If we start from the beginning again, from the middle again, I guess, and we have our aldehyde, now our aldehyde is going to undergo oxidation. And so in this oxidation, what I want to look at is still my number of either oxygens or hydrogens. And so if I look, right, I still have my double bond oxygen here, so that didn't change. But when I look over here, I went from a hydrogen to a hydrogen and an oxygen. So I added an oxygen. And so now you can see this functional group right here, you should recognize as a carboxylic acid, okay? So this was an oxidation reaction. Why is it an oxidation reaction? Because we had an addition of oxygen. Okay. All right, so let's try an example, right? In the following reaction, determine if the organic reactant, benzoic acid, is undergoing oxidation or reduction. So when you look at this, I kind of want to look at how many of each thing I have, but I'm not so worried about this R group, right? What I'm really worried about, that didn't change. See, from one to the other, it didn't change. So I don't really want to look at that. So I'm going to kind of rewrite this, and I'm going to make that circle just an R group for the rest of the molecule, just so I can kind of zoom in and focus on what I need to focus on. So I'm going to look at my same carbon. So I have a carbon here. I have an R group here. So then H2 is telling me that, oh, I don't know why I put another carbon on there. It's telling me that I have 2 hydrogens. So hydrogen, hydrogen, and I have an OH, so an alcohol. So what happened? If you're looking at this molecule, I can count on this side, I have 2 oxygens, and I have 1 hydrogen. Right? And I'm not looking at the R group. I'm just looking at the stuff that I know is going to change. Then I look at my product, and my product went to 1 oxygen, and now I have 3 hydrogens. So what happened? How did I go from reactant to product? Well, I lost an oxygen. Ooh, if I could write. I lost an oxygen. And then I gained 2 hydrogens. So if I come over here, I want to find where I say loss of oxygen and gain of hydrogen. That's right here. So this makes it a reduction reaction. So this benzoic acid is undergoing reduction. All right, so in our cells, we actually have oxidation reduction reactions that go on all the time. This is reduction. Well, okay, so how we break down food is really oxidation. So whenever you eat something and you want to break it down and use it for fuel, we're going to use oxidation. And so remember we talked about combustion before happening inside of the body? And it does happen, but it doesn't happen in the way that we think about combustion, right? It's really a very stepwise process where we do one little thing at a time. And every time we do one step in this process, we're going to transfer energy. And so we call this breakdown of food into energy, we call this cellular respiration. And so if you've had biology, you probably know this formula, right? C6H12O6, that is sugar in the presence of oxygen is going to make carbon dioxide and water, right? So sugar plus oxygen makes carbon dioxide plus water, okay? And then we get energy from that. And so we call that cellular respiration. But this equation doesn't happen in one step. It happens in many, 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 many steps. And we can look at those steps and we can see oxidation happening, oxidation reduction happening inside of those steps. And one example of oxidation happening is when we metabolize alcohol that we drink. So the alcohol, the type of alcohol that we drink is called ethanol. And so ethanol is actually oxidized to an aldehyde, and we call it acetaldehyde. And it occurs by what's called liver dehydrogenase. This is an enzyme that catalyzes the reaction. So anytime you see that ASE on there, that's an enzyme. And so when you hear this, alcohol dehydrogenase, well, ethanol is the alcohol, and it's saying that it's going to dehydrogen it, right? Dehydrogenase. So we're going to take away a hydrogen. So we know that this is going to be oxidation reduction going on because we're changing our number of hydrogens. We haven't even seen the reaction yet, and we know that that's happening. And so a lot of times there are other species, like if you're doing an oxidation reaction, we also have to have the matching reduction reaction. And so I'm going to show you this, and then I'm going to come back to the last couple of notes on that slide. So here's our example. We have our ethanol, C3H2OH, right? F2 is F, and then we put the alcohol, so we call it ethanol. And so how do we know that oxidation is happening when you go from ethanol to acetaldehyde? Well, let's look and see what happens. If we are looking at these, let me add up my oxygens and hydrogens. We're not worried about carbons. We're really worried about oxygens and hydrogens. So I see I have 3, 2, and 1. So that gives me 6 hydrogens. And then I'm going to look at my oxygen, and I have 1 oxygen. Okay, now I'm going to look on the other side. I still have my 1 oxygen, but then I have 4 hydrogens. So 4 hydrogens, right? So what happened? I went from 6 hydrogens to 4 hydrogens. If you are going to go from 6 to 4, this is a loss of 2 hydrogens. Go back to your table over here. Where do we see loss of hydrogen? Loss of hydrogens right here. So this must be oxidation. So that's what we're saying. We have an oxidation reaction happening when we go from ethanol to acetaldehyde. Now, let's look at the other part of that. This happens in the presence of something that is called nicotinamide adenine dinucleotide. Now, it's got a complex structure, but you don't have to know that structure right now. We're going to abbreviate it using NAD+. And NAD+ is going to turn into NADH. And so we leave this NAD the same because we're saying that basically the structure stays the same. All we do is change 1 hydrogen. And so rather than drawing out the whole thing, we use this little abbreviation, and then we just say, does it have a hydrogen or not? And so in the NAD+ form, we don't have the hydrogen. In NADH, we do have the hydrogen. So that's what we're showing here, that we start out with NAD+, and then we end up with NADH. And so you don't really have to know all the things that are in NAD. What you need to worry about is, does it have the H or not? And so when we went from NAD+ to NADH, we gained a hydrogen. So if I look down here, where's my gain of hydrogen? Well, that must be a reduction reaction. Okay, let's see. The other one that's similar to NAD is called FAD, so flavin adenine dinucleotide, and those two are really important in metabolism and things like that. And so we're going to see that in later chapters. Okay, it is time to go do a few problems. Okay, so here's our problems. Are the substances shown in italics undergoing oxidation or reduction? In order to do this, you have to write the little formula out for each reaction. So A, we have copper 2, Cu2 plus, ions in solution forming solid copper. So they're in solution, we put them as aqueous. They're solid, we put them as solid. So now I need to look at my charge. I go from a +2 to what's a solid? Anytime we have a solid, it's always going to be 0. So we go from +2 to 0. So what happened when I went from +2 to 0? How did I reduce my positive charge? I did that by gaining electrons. So I gain, G-A-I-N, gain electrons. And if you gain electrons, come over here, gain of electrons is going to be a reduction. Okay? Now, B, aluminum metal forms aluminum oxide. So aluminum metal, we list it as a solid, and then it's going to form aluminum oxide. So aluminum, it's a solid. This is another one that's going to be 0. So our aluminum goes from 0 to, now kind of do your crossover, reverse crossover. What's happening here? We have a +3, we have a -2, and always go double check. And oxygen really is a -2. There was no reduction that had to happen to make that formula. So we know that our aluminum is going to a +3 charge. So how did you get to that +3? We went from 0 to +3 by a loss of electrons. What's a loss of electrons? That is oxidation. Okay. C, wine containing ethanol, CH3, CH2OH. Sours to vinegar, CH3, COOH. All right, so when we look at this, always circle those things that you can just get rid of. Get rid of them, right? Now we're only looking at things that are really different in the reactants and the products. And so I see here, I have 3 hydrogens, right? 2 here, 1 here. And I have 1 oxygen, all right? Now I look in my products. What do I have in my products? Oh, I only have 1 hydrogen and I have 2 oxygens. All right, so what's happening in this? I am losing or a loss of hydrogens, and I have a gain of oxygen. So where do I have a loss of hydrogen and a gain of oxygens? So right here, we have an addition of oxygen, loss of hydrogen. This is oxidation. Okay, let's see, what's next? Okay, the reaction shown occurs in fuel cells and produces great quantities of energy. Identify the reactant that is oxidized and the reactant that is reduced. What you should automatically recognize is that there's no metal here. Hydrogen and oxygen, those are both non-metals. So you have to be very, very careful that you understand what's going on. So think about these molecules, right? If I have H2, this is my molecule. If I have O2, this is my molecule, right? This is just drawing Lewis structures. So if I look at both of those molecules, I know that these 2 molecules are non-polar, right? They're the same element, and so the bond is non-polar, so the molecule is non-polar. But when I look at water, we know water has that bent structure because it has these 2 lone pairs that just take up so much room that they're pushing down on those bonds. And so it gives it that bent structure, which makes water polar, which is amazing, right? So we know if we drew in our bond polarities, we know oxygen's more electronegative than hydrogen. So those bond polarities point basically towards the oxygen. Now, if we give an overall charge to the entire molecule, the oxygen is going to be slightly negative, and the hydrogens are going to be slightly positive. So what does that tell us about charge changes? Well, so for our hydrogen, we know our hydrogen is going to 0 here, and is going to actually become partially positive. So I'm just going to put a positive sign there because I'm not going to give it an amount. So what's happening is that oxidation or is that reduction? Well, if you're positive, that means you have lost an electron. Now you haven't lost a whole electron. The electron's just spending more time with the oxygen, but it's the same concept. And so this would tell you this is oxidation. Okay. Now oxygen, we start off again at 0. Now we're becoming partially negative. How do you become partially negative? By gaining an electron, and that is called reduction. Okay, so you can always go back to that little table right there to find your answers, right? To identify, is it oxidation, is it reduction? All right, let's see. I think this is the last one. So this actually happens in our bodies. When we exercise a whole lot, we make pyruvate, and our pyruvate gets converted into lactate. And so this happens in an oxidation reduction reaction. And so what we want to do is we want to look at these components and figure out what's being oxidized and what is being reduced. So let's start with our pyruvate and lactate. So what I want to do is first I want to see, what's the same? I can get rid of that. What's the same? Those are the same, so I can just kind of get rid of that. So you actually have a whole lot less that you're looking at. And I think that kind of helps. So here I have 1 oxygen. And over here I have 1 oxygen. Over here I have 0 hydrogens. And here I have 2 hydrogens. So what happened when we went from here to here? Well, our oxygens are the same, but our hydrogens, we gained 2 hydrogens. So what is a gain of hydrogens? A gain of hydrogens is a reduction. Okay. Now our other molecule over here we have to worry about. We have NADH going to NAD. Well, what happened? We had a hydrogen and it's not here anymore. So we lost a hydrogen. A loss of hydrogen is oxidation. Okay. And that's it. Y'all have a great day.